I'm not sure whether you remember. We did this on Tuesday. Can I have attention, please? Say you have an entire population. All right, you have an entire population in Singapore. We are talking about the number of children under 12 in a household. So a lot of data. There are a lot of data. That means a lot of households. Some would have 1, some would have 2, some would have 1, some would have 2, some would have 3, some would have 4, 0, 0, 1, 2, 4, 5, dot, dot, dot. So this is the entire population. It's very big. And the data we're interested in is the mean of X, the population mean of X. And I said on Tuesday that this is something, a data that we're interested in, but is impractical to find. All right? So how do we estimate it? We say, oh, okay, now what do? We take a sample. It can be 3, it can be 30, it can be 500, it doesn't matter, but we take 3 here. Now, this is what I call the sample mean. All right, sample mean. And I said on Tuesday, that this sample mean, can I have attention? This sample mean estimates the population. I think it makes perfect sense. Now, then I went on to ask all of us, what if I want to estimate the population variance? Population variance. So, when we say sample mean is, let's say, the 3 data here, 1, 2, 3. The sample mean is 1 plus 2 plus 3 over 3, you get 2. Now, how do we estimate the population variance? This one. First, I must say, how do we calculate the sample variance? Sample variance has this formula. I don't know whether you remember. It is summation x minus x bar squared over n. Essentially, it means this. That means I have 3 data points. I have 1, 2, 3. Here, correct? What is the mean? The mean is 2. I find x1, the first x1 minus 2 square, 2 minus 2 square, 3 minus 2 square, divided by 3. It actually tells us the average squared distance from the mean. Does it make sense? That means this, if I write down the formula, I think it makes a bit of sense. Okay, I write down. 1 minus 2 square plus 2 minus 2 square plus 3 minus 2 square divided by 3. Can you imagine if all the values are far away from the mean? This one will be very big. Correct? You look at the number line, if 1 is very far away, 3 is very far away, this value will be very big. But if it's 1, 2, 3, the sample variance, now, if we calculate, it will be 2/3. Because I have 1 plus 0 plus 1, so 2/3. Let me first say that in order to estimate the population variance, this is not the sample variance. I write down this first. This is not the sample variance. It is not sample variance. It's very interesting, right? Because, what happened? It's very interesting because you think, in order to estimate the population mean, I use sample mean. In order to estimate the population variance, I don't use sample variance. It's very counterintuitive. I think it's perfectly understandable. It is counterintuitive. Then you ask me, then what can we use to estimate the population variance? The answer is what we call the unbiased estimate of the population variance. Very confusing. Never mind. It means this. You see, the problem is this. The sample variance, it can be mathematically shown, which I will not show. The long-term average value of this will not give us population variance. That means you keep taking 3 samples, 3 samples, 3 samples, find sample variance, find sample variance, find sample variance. The long-term average value of this is not sigma squared. It can be mathematically shown, which I will not show because the mathematics can be a bit confusing for all of us. But I can tell you, in order to estimate the population variance, I will need to use the unbiased estimate of the population variance. The only difference between this and the formula for sample variance is this value n minus 1. Sample variance, if you recall, sample variance is summation x minus x bar square over n. What we're saying is this. Let's be a bit concrete. Let's be a bit concrete. Let's talk about this problem again. So now say, okay, now I'm interested in the number of children in the household, right? I'm interested in the population variance, right? What should I do? I should do this. I should do this. Unbiased estimate of population variance, which we always use S square, is I will take 1 minus 2 square plus 2 minus 2 square plus 3 minus 2 square divide by 3 minus 1. The only difference between this formula and this formula is I will divide by 2 instead of dividing by 3. Then I will get this value called, and then I will get 1. That means this. This is 1 point estimate of the population variance. That means I keep taking 3 values, 3 values, 3 values. The long-term average value of this will give me sigma squared. I know it's very hard to accept. I know it's very hard to accept. I say one more time. This 2/3 is 1 value 1, 2, 3. This is the actual spread of 1, 2, 3. But actually, you're not interested in the spread of 1, 2, 3. You're interested in the spread of the population. You're interested in the spread of the population. This can be mathematically shown that it is not a good estimate for the population variance. However, if you use this, long-term average value will give you population variance. Very counterintuitive, I know, but we just accept it for now. All right, because it's quite different from the mean sample. To estimate this, you use sample mean. To estimate this, you don't use sample variance. That's all you need to know for now. Okay, let's use some numbers for us to work with. Then I think we can. Okay, before that, all this very on your own. Essentially is this. This, whenever we see S square, this is given in MF26. But just take note, when you read MF26, read the formula list. That formula inside S square is the unbiased estimate of the population variance. That means there's n minus 1 here. Whenever you see n minus 1, it means the unbiased estimate. It is not the sample variance. You must make a clear distinction between S square and sample variance. Got it? Yes? All right. Then what is the relationship between S square and sample variance? I think this one you may or may not want to memorize, but I think it's not difficult. Why? Because just remember that sample variance is a 1 over n times something. S square is, S square is 1 over n minus 1 times something. The thing inside the bracket is the same. You got to say, the thing inside the bracket is the same in this one. It's either this form or this form. It doesn't matter whether it's S square or sample variance, it's the same. Then I think it's not difficult to prove the relationship between S square and sample variance. Right? S square, it is given. S square is, sorry, I better change the color of the pen. 1 over n minus 1 which is, all right, which is what? Which is, I need to express it in terms of sample variance. Sample variance is, this is sample variance. Right, this is sample variance. So this is actually equals to n over n minus 1. Correct? Yes? This cancel away, I actually get back this. So therefore this is sample variance. So S square is n over n minus 1 times sample variance. Do I need to memorize this? Actually I don't. Alright, actually I don't. You can easily prove it on your own. Most important is to know that S square and sample variance are different. I repeat one more time, S square and sample variance are different. Alright? Okay, example 10. Let's take a look at example 10 now. Now you are given a random sample of 70 and the results are summarized as shown. Okay? If you notice, the values are very big. Correct? The values are very big. Later, I'll come back to this point of the values being big, yeah? Alright? First question. Calculate the mean and variance of this sample of data. Let's interpret the question very carefully. This sample of data. I always like to put it this way. This is the entire population. The sample of 70 is only a subset, a small set of the population. Now, can we be very clear? What do they want us to find? They want us to find the mean and variance of this one, of this sample of data. Of this sample of data, which means you are not trying to find the population mean, you're trying to find this 70. So you are trying to find sample mean, then you are also trying to find the sample variance. That is the 70 only. Got it? Okay? So, sample mean. Not difficult. Sample mean is, this means, summation means what? Means what? Means x1 plus x2 plus x3 plus x4 all the way plus x70, right? So to find mean means take that value, 10,317, divide by 70. Done. Alright? So I'll be a bit long-winded. I write summation x divided by n, which is that value divided by 70. Then you press your calculator. I don't think it's difficult. What about sample variance? Can we all take note? The question asks us for sample variance. It must be a 1 over n. Got it? The question didn't ask us to estimate population variance. The question asks us for a sample variance. So it must be a divide by n. Questions usually will give us this. Alright? Will give us summation x squared summation x, all you need to do is to put in the values. N is 70. All right, we'll substitute them all in. You will get 1 over 70. Summation x squared is given 1, 5, 4, 0, 2, 3, 1 minus 1, 0, 3, 1, 7 divide by 70, square. Put in a calculator, you get 281 equal. Part 2. Using the above data, find unbiased estimates of the population mean time and its variance. Unbiased estimates of the population mean. So this time, let's take a look at this diagram very clearly. This time they want us to, now we have found the mean of this, we have found the variance of this. Now they want us to find the unbiased estimates of the population mean. That means find a way to estimate the population mean. Now all of us would know that in order to estimate the population mean, we use the sample mean. Correct? So it's actually the same, which is 147. I say again, the mean of this is 147. So in order to estimate the mean of this, it is also 147. Correct? But now, I want the unbiased estimate of the variance. We have found that the variance of this is 281. But does it mean that 281 is an estimate? Is an unbiased estimate of the population variance? No. You have to use the formula. Instead of divide by n, you have to divide by n minus 1. Alright, so you all can fill this in, which I just said. It's the same, it's 147. But to find the unbiased estimate of sigma square, you use the formula. This is, now you can use MF26. 1 over n minus 1. Summation x squared minus summation x. Putting square over n. Alright. Then you 1 over 69. 154031 minus 10317 square over 70. Now just take note, this is 69, this is n minus 1. Put in the calculator, we'll get an answer 285. Notice that it's a bit different. All right, notice that it's a bit different from the 285 is the unbiased estimate for the population variance. 281 is the sample variance, spread of the 70 data. 10? All right. Of course, you can use an alternative. You say, oh, okay, I know the relationship between S squared and sample variance. You can just say this is equals to 70 over 69 times 280.75. Okay, this one is from here. 280.75 equals to 285. 3SF. Now this is an alternative. All right, if you can see the relationship between S squared and sample variance, you use that. Same, doesn't matter. Example 11. A random sample of 10 young boys are taken from a childcare center. The mass of each boy is measured, and the results are summarized. Now, I want to say this. Sometimes In fact, most of the time, the questions will give us in this form, summation x minus 20. What does it actually mean? This means that the x1, x2, x3, x4 are quite close to 20. So when individual values I minus 20, and then I sum them all up, I get smaller values that are easy to manage. Correct? That's how they present the data. That means the values, the individual x values are close to 20, so that I minus away 20 individual, and then sum, I get small values. Easier to manage. Compared to, you realize these numbers are super big, especially the summation. The mean is, if you see, the mean is so big, it's 147. So if I want to make the values easier to manage, where the people who collate the data want to manage, it would be better if they present the data like this. Summation x minus 140 is. Example only, it may not be 140, it can be 100, it can be 130 or something. Why do I choose 140? Because all the values are close to 147. Correct? The values are somehow close to 147. I take summation x minus 140. It will be a values that are easier to manage. But when I present data like that, the numbers are so big. So, example 11, quite nice. Alright, the data, you see 40 and 624 are easier to manage. Find the unbiased estimate of the population mean, mass, and variance. So they go straight to the point. I want to find population, unbiased estimate of population mean and variance. The only problem here is the values are coded in a sense, because all the values minus 20. So how do we deal with it? I let y be equals to x minus 20. So now you are given summation y. This is summation y. This is summation y squared, because y is now x minus, y is now x minus 20. So summation y is actually 40, given summation y squared is 624. Now given summation y and summation y squared, I don't think it's difficult to find what is y bar. Take this, divide by 10, because n equals to 10. Correct? Because n equals to 10. All right? There you get 4. This is the mean of y. It's not the mean of x. The question asked for mean, population means mean of x, because x is the data you're interested in. But we only find mean of y. But later on, let's do that later. Let's find mean of y. And to find the unbiased estimate of the population mean, or population variance, for y. I repeat one more time, for y. Okay? This is the S for y. I think this formula you are quite familiar by now. All we need to do is to plug in all the values. Equals to 1/9. Summation y squared is 624 minus 40 square over 10. All right? You will get 464 over 9. Correct? Yes? But take note, the question requires us to find population mean and variance. This one, the population means x, not y. Because x is the data we're interested in. Look, this is the x. X is the mass of a boy. Cannot be the mean mass of a boy is 4 kg only. You follow what I'm saying? Yes? Cannot be. Doesn't make sense. You have only found the mean of y, you have not found the mean of x. So, okay, this one you can read on your own. Since y is equal to x minus 20, does it make sense that x is y plus 20? X bar is y bar plus 20. Correct? Yes? X bar is Y bar plus 20. So we can easily find the unbiased estimate of the population mean, which is actually 4 plus 20 equals to 20. Then, what is the relationship between Sx squared and Sy squared? Now think about it. What did you do to all the x values? You minus 20 to all the x values. Would it make a difference to the spread of the data? No. Absolutely not. You only minus 20, it would not make a difference to the spread of the data. So actually Sx squared is actually Sy squared, which is 46419, which is 51.6. So this is 51.6. Is that all right? Sorry, I'm rushing through a little bit because I thought, wow, we are a bit tight on time. We need to finish question 1 to 4 for normal distribution. And I know all of us are prepared. That's why you're here, and I don't want to shortchange all of us. I think we should finish question 1 to 4. All right? Okay, let's take our normal distribution.